Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions and the very important concepts of classical mechanics. We will be talking about all these important points in this session which will be helping you for your upcoming CSIR NET GATE, JES, TIFR and other similar exams preparation. So I hope today's session is going to be helpful for all of you guys. I'm just going to check out once whether everything is all right and clear your side or not. I think everything is all right as the audio is clear, video is clear from my side, like I have checked it once. But you can tell me if in case there will be anything which is not clear to you, we will talk about those points then. So let's continue the discussion, guys. So basically, in this session, we are going to talk about the classical mechanics, most important points, concepts, and the type of questions you can have from the classical mechanics part. So this is going to be one of the most important session. I'm just going to show you all those important slides once, and then we will be continuing the discussion as well. So here are some of the slides, like something about me will be there on these slides, and the details about the Unacademy learning app, like the community feature which is there on Unacademy learning app. About that, the things have been mentioned here. Another thing we are going to have is the benefits which you will get if you will take the Unacademy Plus or the Iconic subscription. If you will be taking the Iconic subscription, what are the benefits you will be getting? All that has been shown here on the slide. If anybody will be taking the Plus subscription, what are the benefits they will get? That has been shown there. Another thing is, if anybody will be taking Plus or Iconic subscription or even the Lite subscription, what is the difference between them? All that you can clearly observe here on this slide. Now, next thing, whenever you are going to proceed further to take the subscription, you can use and apply the referral code which is Anjali A Live as mentioned here on the slide. One more thing, guys, I would like to tell you, and that is regarding the latest offer which is going on Unacademy subscription. So if anybody is there who wants to start the preparation under the guidance of top educators and want to take the Unacademy Plus or the Iconic subscription, then this is the latest offer which is going on right now. So you can take either the Plus or the Iconic subscription, okay? And this is only valid for the Plus subscription, the offer which I'm showing you right now on the slide. And what is going to be the offer? You can clearly have a look at the slide right now. You can see that if somebody will be taking the 6 months or the 12-month subscription, how they will be able to get the 1 month subscription free or the 2 month subscription free. And to grab this offer, you need to use and apply the referral code, that's Anjali A Live as mentioned here on the slide. So I hope each and everything, whatever we have considered till now, that is going to be clear to everyone. But in case still, if you will have any question, any query, any doubt, anything which is not clear to you, surely let me know about it. We will try to consider those points then. So let's continue the discussion, guys. We are going to talk about so many important concepts of classical mechanics today in the session, and they will be just all together. Which means if somebody is going to attend this session, they will get to know about all these important concepts of classical mechanics in just one go. Okay, means in this session and just in very less time. So if I'm going to talk about the starting point, for example, they have given you any equation, okay, like random 1 by 1 points we will keep on considering, but your concepts regarding these points will keep on getting clear this way. So let's say they have given you the equation in terms of x and y, okay, and they're talking about the velocity components corresponding to x and y. So what you will do in that case, that is the first question, okay? If you can think about it and you are able to relate like, oh, actually I'm going to take this step to consider the velocity component or to write its expression, to consider it. So that's what you can do, clear? But again, I'm going to let you know what you have to do here. Look at this and just check it out, whatever you are thinking, is that correct or not? So I'm saying, let's say you are going to have x square plus 2y square is equal to 0. Okay, and you need to consider the x component of velocity and the y component of velocity. What you will be doing here, you will differentiate it with respect to t, that is 2x dx by dt plus 4y dy by dt. Okay, and what is this dx by dt? This is the x component of velocity. So 2x vx plus 4y vy. Okay, equal to 0. This is how you can easily get the x and the y components of velocities. Done. It's simple, easy, but whenever we are going to have the questions, many students make mistake in this part. Right now you may be thinking like, oh, how simple and easy it is. But actually when you will have such type of questions in front of you, what you have to do, you will be able to relate it easily once you got to know about this part. I think it will be easy. Now let's talk about the next thing now, guys. So actually now next part is, we all know about the Lagrangian and Hamiltonian very well. That what actually is the Lagrangian? It is kinetic energy minus potential energy. What is the Hamiltonian? That is kinetic energy plus potential energy. Now the next thing is, if you will have the Lagrangian given to you, you should also know about one more thing. It's simply a function of generalized coordinate, generalized velocity and time t. And this is going to be the function of generalized coordinate, generalized momentum and time t. Then in this case, what will happen? In this case, you have to consider this part. What is that? See, since you can have just coordinate and velocity terms here along with the time, okay? So kinetic energy expression will be taken as half mv square, where v can be taken as q dot is, okay? Next thing, minus potential energy form can be mgh or something like that. Anything else can be there, the expression. Now the next part is, once you had this type of Lagrangian expression, if you have to write the Hamiltonian, now I'm not saying exactly this way. At place of m you can have ml square, at place of m you can have m sine theta, but v square term will remain like separately present there, okay? So if you can compare it and you can compare the kinetic and potential energy part separately, what you can do next, you can get or identify the m value, okay? As I have told you, even some extra part will be there, na? Like ml square, m sine theta or something else, 2 upon x, like that. So you will take it as m. Now once you got to know about it, what is the value of m, you want to write the Hamiltonian next. So what it will be? It will be p square upon 2m. Whatever at place of m you will get here, you just have to put it here. Plus whatever potential energy you are having, just write it here. Like if it is mgh, write the mgh there. Okay, this is how you can do the conversion from Lagrangian to Hamiltonian or vice versa. Why? Because if the Hamiltonian will be given, since you know it is a function of coordinate, momentum and time t, so its kinetic energy you will compare with p square upon 2m, and that's how you can get the m value from there. And if you want to write the Lagrangian, this is how you can put it at place of m and you can get your answer. Please tell me, is it all right and clear to everyone or not? If in case there is any doubt anybody is going to have, just mention it and let me know about it. We will be discussing it then. Now, let's talk about the next part. Actually, guys, after this, if we have to consider the next thing here, what is that? That's going to be, let's say you are having any potential expression given to you, okay? Potential expression given to you. How that has been given? We will consider that it has been given as v is equal to ax plus by. And now you want to know about the conserved quantities, okay? Conserved quantity in terms of linear momentum, which means px and py. So what will be the conserved quantity? This is the potential form. Let's talk about that. You have to write the corresponding momentum as px. You have to write the corresponding momentum here as py. You will write, it's going to be b and it's going to be a. What I have done till now, I have mentioned the linear momentum components of x and y this way below the terms, and then we have interchanged the values of a and b, and now we have to change the sign. So sign change means either this sign I have to change or this sign, like any one of the sign I will be changing. If there is no sign in front, which means it's positive still, so if I can make negative here, or I can make negative in the starting one, okay? If it will be negative, I can make it positive. So any one of the sign from the above expression or the given expression we will be changing, and this is how we are just going to get the final expression or the answer of the conserved quantity. Please tell me if in case there is something which is not clear to you or wherever you are going to have any doubt. Okay, we will talk about it then, but if it is clear, that's great. Now once you got to know about this point, let's talk about the next one. If your Lagrangian which is given to you, okay, Lagrangian expression which is given to you, it can be any Lagrangian expression. Now, once you know about the Lagrangian and you want to know whether the energy corresponding to the system for which the Lagrangian has been mentioned is conserved or not. So in that case, you need to know about this part, that if Lagrangian does not depend on time explicitly, what is the explicit meaning? Explicit means actually the t is not present there. Means you can see even right now I didn't take the presence of t anywhere. I can even write mgs t here, just a random expression. So if I will write t here, then Lagrangian will be dependent on time explicitly, but right now it is not. So if Lagrangian does not depend on time explicitly, in that case we can say that the energy of the system is not conserved. But if does not depend on time explicitly, then it is conserved. So if Lagrangian of any given system does not depend on time explicitly, that means the energy of the given system for which the Lagrangian has been mentioned will be the conserved. Okay, energy will be conserved. Now, let's talk about the next part. If I will talk about the next part here, what is that? That's going to be anytime there is a function given to us, okay? Any function, whether x plus 2y, or you can say x squared plus 2x itself, or anything like that. Any function has been given, clear? And you want to know about this part, that whether it is a conserved quantity or constant of motion or not. Okay, this is what you want to know. In that case, what you have to do to know about it, whether it is constant of motion, conserved quantity or not, you just simply have to find its Poisson bracket with the Hamiltonian. If you know the Hamiltonian, you can follow this approach. So just simply find the Poisson bracket of the function given to you. Let's say f is the function with the Hamiltonian. If it is 0, you will say f is a conserved quantity or a constant of motion. Okay, if it satisfies the above condition. So this is how we check it out. Okay, but for that the only thing we need is the Hamiltonian. If we will have the Hamiltonian, we can easily follow this part. Next thing now, if we want to know about, give me a second. If we want to know about the total time derivative, then what we will do? We will be talking Lagrangian or any given function. You want to find the total time derivative for that. So what is the meaning of this thing, that you have to find the total time derivative? It is simply dA by dt is equal to the Poisson bracket of a with h plus delta a upon delta t. Okay, so this is the partial differentiation, this one, second one, and this was the total time derivative part. When they are saying you have to find the total time derivative, means you have to find this. And what is this? This is the Poisson bracket of a with h, and rest delta a upon delta t is representing the partial differentiation. Okay, so whenever you have to find the total time derivative, this is what you have to do. Next thing is, if I'm going to talk about any given Lagrangian expression. So in the Lagrangian, you will be having any generalized coordinate corresponding to the system which will be given to you. For example, x, y, theta, phi, anything can be there. So let's say that coordinate is not present in the Lagrangian, but its derivative is present. It can be for all the coordinates or only for one coordinate, or for not any single coordinate as well. But if it is the case for any coordinate, the coordinate is not present, but the first order derivative is present there, then its corresponding linear momentum will be conserved or constant of motion for that system for which you are observing the Lagrangian. So simply you can get to know about it. If the coordinate is not present in the Lagrangian, but its first order derivative is there, then corresponding to that coordinate, its linear momentum will be conserved or constant of motion. I hope it's getting clear. Next thing, one more part here we need to consider. What is that? So as we have talked about the linear momentum conservation, which component will be conserved? It's good to know that what is the formula or the expression of linear momentum in terms of Lagrangian. That is, like if I'm writing for px, so delta L upon delta x dot. Okay, if I will be writing for just in general pq, okay, that is the q component or q coordinate I'm taking there. So then what I have to consider? I have to consider delta L upon delta q dot for the generalized momentum. Clear? This is what you have to do. This is what you have to consider. Now, once you got to know about this part, what is the next thing we are going to talk about? That's going to be again something from very important topic I'm going to include here. Now, what is that? That's going to be phase space trajectory or phase space dynamics. One statement and your answer can be right if you know it. Clear? And from this concept, from this statement, based on this statement, we got the questions in the previous years. So you can consider, you can expect more questions in the upcoming exams, whether you are preparing for CSIR, NET, GATE, JES, TF, or any other exam, similar exams. So you can expect the question based on this part. One statement and your answer can be right. What is that? So if there is a system given to you, whether it can be a statement regarding that given, okay, and there they have mentioned that it is a, like there is some loss of energy and this is a non-conservative system and you have to draw the trajectory corresponding to it. So first of all, let me just introduce what is the phase space trajectory. Actually, it's going to be the graph between the position and momentum. So if I'm taking the position here, the momentum corresponding to it here on the y-axis, it is not necessary that only x px, it can be z pz graph, like that you can have. Next thing, if it will be a conserved quantity, okay, like, or it is non-conservative system, first of all I'm going to tell you about that. So non-conservative system, for the non-conservative system, what will happen? Its trajectory will be a closed curve. What I mean by that? But no, its trajectory will be connected curves actually. Okay, something like this, something like this. So you can see these are the connected curves. Clear? So for non-conservative system, the trajectory is going to be the connected curve, like I have drawn right now. In this case, you mainly have to focus on this part, that whether its arrow has been shown this way inward or its arrow has been shown this way outward. Like where the arrow has been taken. Now I have made both here, but this part is very important whenever you are going to observe these connected curves or the trajectories. This is for what? For the non-conservative system, for the non-conservative system. Okay, and in this case, what will happen? The trajectories will be the connected curves as we have made them here right now. Next thing, if I'm going to show the arrow inward, means the distance keep on decreasing. If I will be showing it outward, means it keep on increasing. It's not a constant. Okay, means the energy change is taking place. Then while the overall energy, we know that it will be conserved, but in this case, what's going to happen? It's a non-conservative system. So it's showing you some phenomena corresponding to that. Clear? I hope it's getting clear to everyone. But in case if there is any doubt anybody is going to have, just mention it. I'll be talking about that. Okay. This was the example of non-conservative system. That the trajectory will be the connected curves, and how they will be connected curves. That's what I have shown you just now. And the next statement corresponding to the phase space trajectory, which is the momentum versus position graph actually, that no two trajectories can intersect with each other. No two phase space trajectories can intersect with each other. This is another very important statement which everybody needs to know. Okay. Now, corresponding to this, let's even talk about the generalized momentum formula. Like in general, what is the classical momentum? So that is root 2 m e minus v. By relating with this part, I'm going to tell you one more concept here. What is that? If let's say anytime the potential expression is given to you and you need to find the time period dependency on energy. Another condition, potential expression is given and you have to find the time period dependency on energy, means you know this part. That is how the v is dependent on x. Okay, you know this part, means let's say v is equal to ax to the power n, like something like this you are going to have. Now you want to find the time period dependency on energy. What you will do, can you think about it? Can you relate the steps? Can you consider that what are the steps you will be taking and how you will be reaching to the answer for this type of question? If you can, that's great, but if you can't, let me tell you about the steps you have to take. So you will be taking or relating it with the concept of action angle variable, which is integration p dq. Okay, here what you have to do, you know p is equal to root 2 m e minus v. From here we will be taking the j proportional to e to the power half. But for q coordinate, what you will do, you will take x is equal to b is a point where the potential energy is equal to the total energy. So you are going to find that b value from here, that will be e upon a to the power 1 by n. It is proportional to e to the power 1 by n. Just take it here. You got the j dependency on e this way. This is just a kind of trick or the approach we are going to follow. Now you want to find the time period. T is equal to delta J upon delta E. Just you have to differentiate it, and this is how you will be getting the T dependency on E. That's it. This is how you will be able to get your answer. Please tell me if in case there is any doubt. This was the approach, okay, which you have to follow to get the answer for such type of question. So as I've told you in the starting of the session, that this one single session can help you to learn so many concepts. I hope you are gonna get that how you are gonna learn so many concepts. That's true so quickly, easily, and in just very less time. Then if you are gonna focus on the statement I'm gonna share, I'm gonna tell you here, okay, and then you are gonna work on similar questions, so you will find like, oh, it's so simple and easy for you to like solve the related questions and to get the answer for them. Tell me if in case there is anything which is not clear to you guys. We will be talking about it then. But if everything is all right and clear, that's great, great, great. You can just mention it in the comments if there is anything which is not clear, or wherever you are going to have any doubt. Just gonna check out your comments here. And if everything is clear, we can keep it this much right now in the session. Okay. And let me just show you some of the important slides again. Look at this. This one is about the latest offer, guys, because right now even so many new courses are starting on Unacademy. So if you are the one who don't want to miss out these important courses by the top educators, and you want to join and attend the regular live classes of well-structured and well-planned courses by the top educators, then you can take the Unacademy subscription. And even right now this mega offer is going on, as per which you will be able to like get the benefits as shown here on the screen or mentioned here on the screen. Also guys, to grab the offer you need to use and apply the referral code, which is Anjali Live, as mentioned here on the screen. So by using and by applying this referral code, you will be able to grab the offer or will be getting the discount in the total subscription amount as well. I hope it's clear to everyone. And what are the benefits you will get after taking the subscription? Let me just show you the slide regarding that as well. So here is a slide which will be making it clear to you that what are the benefits you will get if you will take the plus iconic or the light subscription. And anytime whenever you will proceed further to take the subscription, you can use and apply the referral code, that's Anjali Live, okay, because it will be helping you a lot to take your preparation to the next level when you will be starting the preparation under the guidance of top educators. So we are going to keep it this much right now. We will be having more and more important sessions in upcoming days. Thank you so much everyone for joining this session and for attending.